Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over the CrackSAT questions, specifically numbers 19 through 21. As usual, I go through the problem very quickly actually, and then afterwards I go in depth as to how I was able to get to the answer real quick. So I'm going to go ahead and get started. So for number 19, this equals this. Okay. So first things first, I'm going to do this. Okay. Okay. So for this question, my final answer is D. And now I'm going to go ahead and explain to you how I was able to get to this answer. For number 19, there's actually two ways to do this problem. So the first way is if you do remember the trigonometric identities. So I'm going to write that term down in a different color. So trigonometric identities, you actually could use the trigonometric identities to help you solve this question out. And so what I mean by that is that what you can do is that you have to recognize that when we do cosine of 2 theta, there's an identity that does exist that will work really well with cosine 2 theta specifically, which is 1 minus 2 sine squared theta. Okay, and so what happens is that I could realize that if my theta, whatever my value for theta would be, that will help me sort of solve this out. Or aka, since this part right here, sine theta is 1/3, it's technically going to be this, 1 minus 2 times 1/3 squared. Or aka 1 minus 2 over 9, which is going to be 7 over 9. And that's how you get to the answer D. But the second strategy is what I actually personally did. And the main reason why I use this strategy is just because I tend to forget these identities. It's not every one of them do I forget, but sometimes it's inconvenient to forget the identity and be stuck on that. And so what the concept that I personally use is called the inverse trigonometry. Okay. So how inverse trigonometry works is that I actually do, and I'm going to write this on a separate piece of paper just so you could see what I did, is that you could actually solve these the theta out. So the theta, or aka the missing angle out, by doing this method. So since I know sine theta equals to 1/3, inverse trigonometry lets me do is I can move this sine function over to where the 1/3 is. And so that's what I exactly did. I realized that I could do the inverse sine, or arc sine as some people call it, and solve for this theta value. And so I punched it into the calculator, and when I punched it into the calculator, the value it gave me was 0.339837. And so afterwards, I just simply took this cosine 2 theta and the cosine 2 times that 0.339837, and I'm going to write it properly, 9837, and it gave me a value of 0.777, like continues on to 8. And so afterwards, I looked at the decimal values that were provided on the sheet. And so, well, I need to look for one that's 0.7778, and so it's not going to be A and B automatically because they're both negative values. And so I kept going to C. I know that 2/3 will actually be 0.6667, and I know it's not 1, so I knew right off my final answer will be D, and I confirmed it on the calculator where I did 7 over 9 and checked the decimal value, and it matched up. And thus how I was able to get to the answer for number 19. And to continue to the next question, so for number 20. Okay. Okay, for number 20, my final answer for this question is A. And now I'm going to go ahead and explain to you how I was able to do this question. So for this question, the concept, and I'm actually going to move it up, sorry about that. So the concept that how I was able to do this question is based on the concept of simply inverse. Okay, and I'm going to write the term inverse. And so what I mean by inverse is that it lets me switch the values that I need to, I need to switch to x and y in order to be able to solve it. That's the idea behind inverse. And so what I mean by that, and I'm going to go ahead and get a piece of paper out, is that I simply did was switch to x and y for the square root x minus 1, and then so that y is by itself. So that's what I exactly did. So in the beginning, the question states is y equals to square root x minus 1. And so Afterwards, what I did was that I switched y and x. So it'll be x equals to square root y minus 1. And then afterwards, the process is that I can't take care of any of these external functions like this until I get rid of any extraneous or outside things that are going on. So this negative 1, I needed to move first. So I moved it, did x plus 1 equals to square root y. And in order to get rid of a square root, I have to square both sides, very simply like this. Personally, when I was doing this question, I automatically skipped this step and sort of distributed it, but realized that on the answer choices, actually in its base, this format, where it's still in a squared format, and thus how I was able to get to x plus 1 squared, thus why my final answer for number 20 is going to be A. And that concludes my explanation for number 20. And to continue on to the next question for number 21. So 21 states this one. Divided by x plus 1. Okay. Okay, for number 21, my final answer for this question is going to be A, and now I'm going to explain to you how I was able to get to this answer. So when I'm doing number 21, the key concept that you do need to know for this question is simply division. So division could be broken down into two different methods, whether it's long division, which is the method I did, or you could use what we call synthetic division. Either one will work. Personally for me, I like long division just because everything's laid out and I never forget how to do certain things. But that being stated, both will get you to the same answer. And so I'm going to show you how I did it based on my long division. So when I'm doing long division for this question, and at least what I've seen students do when they do these type of questions, is that they understand that they could actually divide this or set it up. And then they get stuck because they think that if we set it up to this format, we cannot get to the answer. But actually, when you are doing these type of questions, you do want to go through the whole procedure of doing the problem as if it is an actual constant here, not L. By doing this, you could actually solve the variable in the end. And so what I did was that first I recognized that I need to multiply this value x with whatever value on top to get to 4x squared. That's how I got 4x. So x times 4x is 4x squared. And I continued on. 1 times 4x is 4x. And so afterwards, you always have to subtract based on the long division process. And so because the negative distributes, it'll be 6x minus 4x, which is 2x, and I bring down the L plus L. To continue the same method again, now I need to cancel out the front value, which is 2x. And so I did plus 2, because x times 2 will be 2x. 1 times 2 is 2, and I subtract once again, and these will cancel out, and I end up having L minus 2. And in the question, it states that the remainder will be 2 right here. And so that means that this value I got L minus 2 has to equal to 2 since that's my remainder. Thus how I'm able to solve for L in the very end. And thus how I was able to get to the answer L equals to 4, which is my answer A. And that concludes my explanation for today. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, follow us on Twitter so that we could continue to make content like this. I hope you have a wonderful day.